other people, if there is anybody, they can always join. So so far we have seen the matrices, the properties of matrices, operations on matrices, determinants, some properties again of determinant, the inverse, adjoint, minor, all those things. Okay, so I want to just check, by giving a couple of, we can take a couple of problems and check our knowledge. Okay. Before that, okay, so let's get started with a couple of problems. Okay, just to revise whatever you have already learned. Okay. P equal to 1. Oh, I have to only write down. Matrix, is very difficult to type. So there's a matrix P, okay, which is defined like this: 1, x, 0, 1, 3, 0, 2, 4, minus 2. Okay. This is your matrix P. Okay. Right. So this is the matrix P, and it's given that if P is the adjoint of 3 by 3 matrix A, and the determinant of A is 4. Okay. Then find X. Okay. So this, I suppose you can do from whatever you learned in the last couple of classes,
Yes,
and
sir.
whatever you have learned in your school also. Yeah. Please do this, and yeah. Actually, this problem has got a few options also. So these are the 4 options given for the answer. Let me know if you have done. You can raise your hand if you have done. Vedant has done it. Okay. Ranjal, are you able to do it? Are you doing it or need help?
I'm doing, sir.
Okay. Check 080 Santosh. Hi Santosh, good evening.
Good evening, sir.
Santosh, you are from 12th or 11th?
Sir, 11th இப்போ படிக்கிறேன் சார். Now studying 11th, sir.
Now studying 11th. Okay, okay. So this class, this is syllabus is 12th. So you can be there, but you may find it hard. Tomorrow there is going to be a class for 11th. Okay.
Sir, I attend.
Did you attend the last class? We had a class for 11th also. We were discussing the 10th exam, 10th board problems. Were you there for that? Last Wednesday, I think we had the last class.
Yes, sir.
Okay. Okay. Did you attend the other classes where we discussed about the matrix and determinants?
Yes, sir. Yes, sir. Yes, sir.
Okay. So then you can try to work on this problem. Hello, Pranjal, have you done?
No, sir.
Okay. So I think we are. We need to make go forward. Okay, because time is running. Okay.
Okay, sir.
Right. Vedant, what did you get the answer as? What's your answer?
Sir, 11.
For 11. Okay. Okay. So let me explain. Okay. So okay. So here P is the adjoint of A. Okay. Now it is given that adjoint of A equal to this. This is your adjoint of A. Okay. Now determinant of A is given, not determinant of adj, but determinant of A is given. Adj is given and det A is given. Now, what is the relation between adj and det A? So suppose you take the det of adj, okay, determinant of adj, that we can calculate from this, right? So what is the relation between the determinant of adj and determinant of A?
Determinant A over n minus 1.
Right. Do you all remember, Pranjal? We discussed this, right?
Yes, sir.
Determinant of adj is determinant of A to the power of n minus 1. Here n is 3, right? It's a 3 by 3 matrix. So n minus 1 will be 2. Okay. So that is determinant of A square. So determinant of adj is going to be 4 square, which is 16. Okay. Now, here is a matrix. Its determinant value is given. So you can try to write down the determinant of this matrix. So determinant of adj is what? From the figures that are given, can we write down the value in terms of x? So that we can equate it to 16 and solve for x. Okay. So how do you, what is the best way to, this is determinant of adj is this. Determinant determinant of 1x0, 130, 2, 4, minus 2. Determinant of at j equal to 16. This is what is given. So can we expand this? This determinant, if you expand, the best way you should always do is take the row or column which has got maximum zeros. Okay. So this column has got maximum zeros. Okay. This column, since it has got maximum zeros, so you can take that. Then it will be 0 into its cofactor, and then again 0 into its cofactor, and this minus 2 into its cofactor. So, so since 0 into anything is 0, right? So what remains is only this minus 2 into its cofactor. So, right. Minus 2 into its cofactor is what? 3 minus x. 3 minus x. Okay. So minus 2 here, the sign is again, this it is 3, 3, right? This element is third row, third column. So 3 plus 3 is 6. Therefore, it is plus. Otherwise, you have to put, minus. So in this case, that minus sign doesn't come. So whatever is there, minus 2 into 3 minus x is what you have to put. Okay. So now we can solve for x. What does this give? Minus 6, right? Plus 2x equal to 16. Minus 6 plus 2x equal to 16. 2x equal to 16 plus 6. So x equal to 11. Okay. Vedant, I think you completed it. You got the right answer, right? This is the way you did, right?
Same way I did, sir.
Very good. Very good. Very good. Okay. Let us do one more problem. Okay. Let us do one more problem, which is one or two more problems. I want to make sure that you understand these properties. This is very, very important. Okay. Okay. So it's given that A equal to 3 by 5, 4 by 5, x 3 by 5. This is the matrix A. And also it is given A transpose equal to A inverse. Then find x. Now all you have to do is write down A transpose, write down A inverse. Okay. So when you are writing A inverse, it is enough if you get the term that will come exactly here in the A inverse. Okay. So then you know what term appears in that place for A transpose. So equate A transpose and A inverse and solve for x. Yeah, you can raise your hand if you're done. Are you all done?
Yes, sir.
And Vedant?
Yes, sir. Done, sir.
Done. Very good. Very good. So what did you get?
Minus 4 by 5.
Minus 4 by 5. What did you get, Pranjal?
Minus 4 by 5.
Minus 4 by 5. Okay. Okay. Very good. Minus 4 by 5. Let me just minus 4 by 5. Did you get only one value for x or did you get two values for x? Possible values when you
I
solved
got
it.
only one value.
You got only one value. Okay.
Let me check
And-
once again.
Yeah. What about you, Pranjal? Did you get one value or two?
Yeah, sir.
One value, sir.
So if we take
Okay.
x square, then we get two values. But in the matrix, there's another term with the x. So while equating with that term, we are getting x single value.
Let's just do it. Let's do it. Okay.
Yes.
So what is A transpose? 3 by 5. Put columns as rows and rows as columns. That's all right. 4 by 5. 3 by 5. This is your A transpose. Now to do the A inverse. So you have to do a few things. Minor is 3 by 5 x 4 by 5 3 by 5, right? Minor means for every term you take out the row and column and whatever is remaining I write that. Okay, for example, for this term you take out the first row and first column, so whatever remains is this one, which is 3 by 5. Similarly, for every term. And then cofactor, you can write here, cofactor is, so multiply by minus 1 to the power of I plus j. So that means this term will not change in sign. This will change. This will change because this is 2 I equal to 1 and j equal to 2. This is I equal to 2 and j equal to 1. The other terms are 1, 1, 2, 2. So those won't change. This is your cofactor. So at j will be transpose of cofactor, which is 3 by 5 minus 4 by 5 minus x 3 by 5. Right. And inverse will be 1 by det A, right, into at j. So we need det A also. What is determinant of A? Determinant of A equal to A into, if you take the first row, A into its corresponding cofactor. Okay. So that is one easy way. Okay. Always, 3 by 5 square, this is 9 by 25 minus 4 by 5 x. So I'm writing like that, 9 by 25 minus 4x by 5. 4x by 5. Right. Now, inverse A. A inverse is equal to 1 by this, 1 by determinant of A. So this I will simplify now. Okay. 25. So this is 9. And this will be 5 into 4x minus 20x. Right? 9 into 20x by 25, I write like that. So A inverse will be 1 by det A, which is 25 by 9 minus 2x, 20x. Okay. Into at J, right? 3 by 5 minus 4 by 5 minus x, 3 by 5. It is given that this is equal to transpose. Yeah, 3 by 5 x. 4 by 5, 3 by 5. Okay. So here each term will be multiplied by 25 by 9 minus 20x. If you take this term, for example, this term will be 25 by 9 minus 20x into 3 by 5. Okay. And that is equal to 3 by 5. Okay. So that means this will get cancelled, right? It will become 1. So 25 by 9 minus 20x is equal to 1. So 25 equal to 9 minus 20x. So 20x, I'm bringing it on the left hand side, is equal to 9 minus 25 equal to minus 16. Is equal to minus 16 by 20. Minus 4 by 5. Okay. Very good. This is what you got, right? Minus 4 by 5. But if you take one of the terms, you will get another 2 answers. But anyway, only one will be valid because it has to satisfy the entire, all the 4 elements should satisfy. So only this minus 4 by 5 will satisfy all the 4 elements. Okay. So hope you all got it correct, right? Pranjal and Vedant?
Yes, sir.
Yeah, same way, sir.
Okay, good. I want to do one more problem. This A equal to 2, 1, 0, 1, 2, minus 1, 0, 1, 2. And it is given that determinant of is equal to 16 to the power of n. Find n. Okay.
Sir, what formula we can use for it? Determinant a power.
Yeah, what is determinant of edge of j
Yeah,
in
that
terms of
formula.
determinant of a? Yeah,
I forgot the determinant a power n minus 3 or.
think. You can look back. You can look back your note. You can look back look at your book. And what about Pranjal? Are you doing? You done?
Yes, sir.
Very good. So what did you get the answer as?
Sir, n is equal to 4.
N is equal to 4. N is equal to 4 is not correct actually. But can you tell me how did you do?
Sir, h
Pranjal?
square. So delta A is equal to 8. 8 square is equal to 64. Then edge of edge A is equal to edge of A raised to n minus 1. 8 root 4 is equal to 4096. Then edge of edge A is equal to edge of edge A n minus 1. Your final answer is 16 raised to n is equal to 4. Answer is 65,436.
Okay. You did not calculate all that, but let me write down some steps. What is the formula for edge A? Determinant of edge A equal to determinant of
Determinant
A
a
to the
power
power of n
whole
minus
square.
1 whole cube.
Okay.
Right?
Yes, sir.
It is the same thing. You did it in 3 steps. I am just putting it in 1 step. Okay. So this particular formula, if it happens, the edge is there for 4 times 5. We discussed this. Okay. Then it is it is equal to determinant of A to the power of n minus 1 to the power of how many ever times that edge is there. So since there are 3 times, it is n minus 1 whole cube. But if there are only 2 times, it will be n minus 1 whole square. If only 1 time, it will be just n minus 1. Okay. Now here, what is n? N is 3, right?
Yes, sir.
N is 3. So 3 minus 1, 2. And 2 cube is 8. Right? So edge A equal to determinant of A to the power of 8. The determinant of edge A is equal to determinant of A to the power of 8. Now what is determinant of A? That we can calculate. No, A is given. So what did you get determinant of A as?
Sir, 8, sir.
Determinant of A you got as 8, right? And what about you?
Yes.
8. Okay. It's correct. Determinant of A is 8. Okay. Now, therefore, this adjudge A determinant is equal to det A to the power of 8, which is equal to 8 to the power of 8. 8 to the power of 8. And it is given that it is equal to 16 to the power of n. So, now this reduces to 16 to the power of n equal to 8 to the power of 8. And we have to solve for n. Did you get this far, Pranjal?
Yes, sir.
The same thing you got, 16 power n equal to 8 power 8. Did you get like that? Then what will be the value of n? This is again, they're given a small twist. You go back to, exponents. Those are all in your 11th class, right? The exponents, formulas for solving for n based on this type of equation. You convert both sides to the common base, which is 2. Okay. So convert both the sides to 2 to the power of whatever. Okay. So then you can equate the exponents. Let me know if you have, if any of you determine the value of n.
Sir, n is equal to 3.
N is equal to 3. No.
N is,
Ranjal, what did you say?
N is equal to 6.
N is equal to 6. Okay. So n is equal to 6 is the correct answer, Vedant. So like I said, no, this 16 can be written as 2 to the power of 4. 8 can be written as 2 to the power of 3. You have to equate the bases. Okay. So now you can write 2 to the power of 4n equal to 2 to the power of 24. So once you equated the bases, then you can equate the exponents. 4n equal to 24.
Yes, sir.
Okay. Okay. So I think that's about. I hope this has helped you in revising whatever we learned so far. Now let me go to the next some more topics within matrices and determinants. One thing I did not talk about is the area of triangle, because I think area of triangle comes in 11th standard. But still, you need to know that sometimes there may be problems. Do you all remember the formula for area of triangle using determinants?
So half into base divide, but
Half
using
into base.
determinant.
The 3 vertices are given. Let us say this is a triangle. The vertices of a triangle are 2, 7, 1, 1, 0, 10, 8. Find its area. This is one of the applications of determinants, which you have studied in 11th standard. I don't know about Pranjal. Did it come for you in the 11th standard or not?
Yes, sir.
You studied this. Okay. So then solve this. It's important that you should be thorough with 11th and 12th portions both. Could you locate the formula? Can somebody tell me what is the formula? Suppose these vertices are x1 comma y1, x2 comma y2, and x3 comma y3. Then the area of the triangle is given by first row you write as 1, 1, 1. Okay. Second row you can write as x1, x2, x3. So if you simply evaluate this determinant, that will give you the area of triangle. Okay. Oh, half into half into this determinant. So now you please calculate this and tell me.
23.5.
23.5. Very good. So that is correct. So in this case, you put x1 equal to 2110 and 718. So you have to just calculate this, and it is going to give you 23.5. Okay. Did you get it, Vedant?
So doing.
Okay. I'll give you a minute. Complete it.
Yes, sir, completed.
Completed? Very good. Very good. Okay. So let's move on now. Okay. So we have talked about determinants, matrices, properties, and all that. One of the important application is in testing the consistency of a system of equations. One of the applications of this matrices and determinants is testing the consistency of a system of equations. Okay. So we already saw how to solve a system of linear equations. So we saw the matrix inversion method and the Kramer's method. Those two techniques we saw in the last class itself. Okay. So I'm not going to go into that once again. Okay. So now I'll tell you how to test based on there is a method called rank. Okay. So you need to understand what is a rank, and Gauss-Jordan method of converting. It's not Gauss-Jordan method. Converting a matrix to its row echelon form. If you convert it to a row echelon form, that is the way you determine the rank of a matrix. I will tell you how you go about using an example. Okay. Okay. So there is a system of equations. It is called rank. Rank of a matrix. Rank of a matrix is the highest order minor. Okay, that doesn't vanish. The highest order minor which is not equal to 0. Okay. So if there is a 3 by 3, so suppose there is a matrix given, let us say take a matrix. Okay. Let us take a system of equations. Okay. X minus y plus 2z equal to 2x plus y plus 4z equal to 7. 4x minus y plus z equal to 4. So you have to solve this problem. So we already saw that this can be solved by the Cramer's method and matrix inversion method. But the thing is, both those methods will work only if it is a non-singular matrix. Because inverse can be found out only if it is a non-singular matrix. Similarly, Cramer's rule also says, for each x equal to delta 1 by delta and then y equal to delta 2 by delta. We saw that, right? So at the denominator, the delta, which is the determinant value, comes. Therefore, if it is a singular matrix, the determinant is going to be 0, then you cannot apply both those methods to solve an equation. Okay. So that is when you use the rank method or row echelon approach. Okay. Row echelon method, I'll tell you, is like it is basically that's the way we solve the equations. Write down the coefficient matrix. In this case, the coefficient matrix is 1 minus 1.
Sir?
Ah.
Sir, if determinant is 0, we cannot use matrix inversion method.
Yeah, we cannot use matrix inversion method. Because the inverse does not exist, no? If the determinant is 0.
Yeah, yes, sir. 1 by determinant does not exist.
Yeah, so it does not exist. Therefore, you cannot use the matrix inversion method. Okay? Similarly, you cannot use Cramer's rule also. Okay. So in that case, you have to use only this rank method. Okay.
Yes, sir. Okay. So we write like this. Okay. So this matrix 1 minus 1 2, this matrix is called coefficient matrix. This whole matrix, this bigger matrix, this is called augmented matrix. You augment it with the right hand side values, then this becomes an augmented matrix. So now for when you use row echelon method, what you try to do is you try to make these terms, try to convert it into a upper triangular matrix. If you want to make these things as 0, make them 0 by suitable transformations. 0. Okay. So if you do that, so then obviously it will become like easily solvable. Okay, let's just do that. Okay, the steps are like this. To finding out the rank, these are the steps. The first thing what you do, you make this element to 1. Okay, it is already 1 in this case, so that is good. So now what you do, you have to make this this as zeros. Okay, that means what transformation we can do? Row transformations we should do. Okay, R2 we convert it into R2 minus 2R1. If you do that, because 2 minus 2 into 1, this will become 0, right? Similarly, R3 you convert to R3 minus 4R1. So then this will also become 0. So in one step,
So we can try to we can make both these terms as 0. Okay. So let's just do that. When you do that, the same row transformation you do on the augmented, the entire matrix on the right hand side also. Okay. So you have to do only row transformation, not any column transformations. Okay. Only we do row transformation. In this way that I have written. Okay. Your goal is to make all the terms below the diagonal to 0, so that this becomes like a upper triangular matrix. So then that is called, this is in a row echelon form. Okay. So let's do this. You do this transformation. So first row we are not touching, so I'm just leaving it as it is. 1 minus 1, 2 and 2. Second row, what we are going to do? 2 minus 2r1, right? R2 minus 2r1. R2 is 2 minus 2r1 is 2 into 1, 0. That is our goal. We want to make this 0, so we did that. So do the same thing on every other term in the row. So again, R2, 1 minus 2 into minus 1. So I'm doing it mentally. If you want, you can write it down and do. Okay, 1 minus 2 into minus 1 is 1 plus 2, which is 3. Okay, this one is 4 minus 2 into 2, so that is 0. This is 7 minus 2 into 2, that is 3. 7 minus 2 into 2 is 7 minus 4, which is 3. Okay, so we completed row 2 transformation. Then row 3 transformation. Okay, row 3 is what? R3 minus 4R1. R3 minus 4R1, 4 minus 4, 0. Minus 1 minus 4 into minus 1. So minus 1 plus 4, that is 3. Okay, so this one is minus 1 minus 4 into 2. So minus 1 minus 8. So minus 9. Right? It's 4R1, right? 1 minus, so this is minus 7. I missed it. Okay, so this is 4 minus 4 times 2. So that becomes 4 minus 8. Okay, do you understand what I did? So anybody, please try to do it yourself and make sure that this is very clear to you all. Okay. Ranjal, did you understand?
Yes, sir. In previous class, I have done this method.
Very good, very good, very good. Okay. So next what we are going to do is make this to 0. That means what I will do is R3, I will make it as R3 minus R2. Okay. So I'm not touching R1. Or not touching R2 also. I'm going to write R3 as R3 minus R2. That means 0, 0, minus 7. So this is minus 4 minus 3. This is minus 7 also. 3 minus 7. 0, 0, minus 7, minus 7. Okay. Now, once you have made it a lower triangular, upper triangular matrix, and you have, all the diagonal elements like this, then the rank of this matrix is equal to 3, because once you are converted to row echelon form, there will be, if there are no rows with entirely zeros, okay, so that only you exclude. Okay, there are no rows that are having all zeros, right? So that means the rank of this matrix is 3. The rank of coefficient matrix. Rank of augmented matrix is also 3. Okay, so augmented matrix means you look at the whole matrix, like 4 into 3 matrix. So and remove the rows that are having all zeros. Since there are no rows that are all zeros, we don't remove any row. So the rank is 3 itself. Okay, so that is how you calculate the rank of coefficient matrix and augmented matrix. Okay, so once you did this, if the rank of coefficient matrix is equal to augmented matrix, okay, first of all, if the rank of the coefficient matrix is equal to the number of variables, there are 3 variables, and there are the rank of this matrix is 3. That means this determinant does not vanish, and therefore this has got a consistent solution, consistent and unique solution. When the rank of coefficient matrix is equal to number of variables. This is the condition. Okay. So if the rank of the coefficient matrix, which is 3, is equal to number of variables is 3, if it is like that, then it is having a unique consistent solution. So this one, we can easily solve it once you have converted into this row echelon form. So this equation tells us that minus 7 is z equal to minus 7, right? Minus 7 is z equal to minus 7. This gives us z equal to 1. The second equation tells us 3y equal to 3. Y equal to 1. First equation tells us that x minus y plus 2z. Equal to 2. That means x minus 1 plus 2 equal to 2. It gives me x equal to, this will get cancelled, so x equal to 1. So the solution, this is having a unique solution, and the solution is x equal to 1, y equal to 1, z equal to 1. Okay. So suppose this this method will work even when determinant is 0, because if the determinant is 0, what will happen? You will get a 0 line. So in that case, the rank will be less than the number of variables. So in that case, it will either have multiple solutions or it will have no solution, inconsistent, depending on whether the rank of the coefficient matrix and rank of the augmented matrix, if they are both equal, then it is going to have multiple solutions. If the ranks are coming differently, then it is inconsistent. Okay, so that is the rule. Let's take one more example. I hope you follow, right? You follow what I said?
Yes, sir.
Yes.
Yeah, I think yeah, you might have studied this in your portions also. So I'm just repeating. So okay, let's take one more problem. Okay. So here the determinant value is 0. I know that. Okay. For this problem, the determinant value is going to be 0. So you cannot use matrix inversion or Cramer's rule to solve this set of equations. Okay. So you can only use this rank method. So you write like this. Okay. So what is the first step? You can make it 1, or even with 3 you can work. Because if you try to make it 1, it will become all fractions, 1 by 3, 1 by 3 and all. So if you're comfortable, leaving it as 3 also, that is fine.
We can replace the rows.
Replace the rows. Yes, we can replace the rows. Okay, that we can do. Okay, but then you should remember that this is y. Okay, and first row is not x. First row becomes y, and second row becomes, so that you should remember when finally writing the solution. You should not write x equal to. Okay, that you have to be careful. Okay, so you can write like this: 1 minus 3, 2. Oh, sorry. It doesn't matter. It doesn't matter really. 1 minus 3, 2, 1. You can write it in any order. 3, 1, 1, 2, 7, minus 1, 4, 5. Okay. So the values are the x, y, z are only for the columns. Okay, not for the rows. The row you can write it in any order. Okay. Right. Now, what do you do? R2 you can write it as R2, convert to R2 minus 3R1, and R3 you can convert to R3 minus 7R1. Okay. So first row doesn't change. Second row, 3 minus 3, 1 minus 9. So 1 plus 9. So this is 1 minus 6. This is 2 minus 3. Okay. And write this one also. 7 minus 7R1. So 7, 0. Minus 1, minus, minus 7 into minus 3 is plus 21. So 20. So 4 minus minus 7 into 2, right? So minus 14. 4 minus 14. So 5 minus 7. Okay. Now you see, if you try to make this as 0, okay, how can you do that? R3 we change to R3 minus 2R2. Let us apply that. Zero, 0, minus 10, minus 2 into minus 5 is again 0. This one also becomes 0. Yes. Right? Minus 2 minus 2 into minus 1. So minus 2 plus 2, 0. So now you see this rank of coefficient matrix equal to 2. Like I said, no, you remove the 0 rows and see how many remaining rows are there. With the non-zero rows, how many rows are there? That is your rank. Okay, and number of variables is 3. So if number of variables is 3 and rank is 2, either there are infinite solutions or it is inconsistent. That is dependent on whether the rank of the augmented matrix and rank of the coefficient matrix is the same. Okay, so in this case, you can see that the rank of the even if you take the augmented matrix, this whole row, since everything is 0, this will vanish. Okay, so the rank of coefficient as well as augmented matrix both are 2. You see, if this is happening, okay, both are equal, then it has got infinite solutions. It has got okay. If it so happens that when this becomes 0, 0, 0, and this is non-zero, okay, sometimes depending on the value on the right hand side, this may become 0 or this may become non-zero. If this becomes non-zero, then the rank of coefficient matrix is 2 and the rank of augmented matrix is 3. If it comes like that, then you can say that this is a inconsistent set of equations. There is no solutions if that happens. Okay, because in this case you see a 0 equal to some value will come, which is inconsistent. So therefore, this is how you say whether a system is having unique solution. There are only three possibilities: either it will have unique solution, consistent and unique solution, consistent and infinite solutions, or consistent and inconsistent. Okay, so you convert it into row echelon form in this way, and you see the rank. From that you can tell which of the three this satisfies. Okay. So any doubt?
No, sir.
Okay. So I think it is. We can try to do one more problem. Let's just do one problem today. Okay. 3x plus 2y plus 7z equal to 0. 4x minus 3y minus 2z equal to 0. 5x plus 9y plus 23z equal to 0. So try to solve this set of equations. See, if one thing that you have to notice is, if the right hand side is all 0, this will never be inconsistent. Okay, because there is always a solution where x equal to 0, y equal to 0, or z equal to 0. Okay, if you put all three zeros, all the equations will be definitely satisfied. Okay, so it will not be inconsistent at all. So it will have only either a unique solution or multiple solutions. So that you will see when you convert it into row echelon form. If you get any zero rows, then if the rank is less than the number of variables, then it is having multiple solutions. If the rank is equal to the number of variables, then it is having unique solution. So can you do this?
Doing, sir.
This set of equation where all the right hand side values are 0. This is called homogeneous equations. Please tell me if you have done. Okay. Good, Vedant. Pranjal? Pranjal, did you do?
No, sir.
Okay.
Sir, we have to find x, y, and z.
Yeah, then you have to find x, y, and z.
Sir, we
Okay.
then shall we take z is equal to k, like
Yeah, that's right. I'll come to that. I'll come to that. Okay. So let's do that transformation now. Okay. So the transformation we can do is, I can either divide by 3 to make this as 1, or we can even work like this with value of 3 is also fine. So long as we are able to get these elements to 0, we are good. Okay. So what I will do is R2 I will transform to 3R2 minus 4R3 R1. A little complex, but we can still do it. I find it comfortable compared to dealing with fractions. Okay. R3 is 3R3 minus 5R1. Okay. So I'm just interchanging these coefficients here. Okay. 3 and 4, 3 and 5. Okay. So you can see that 3 into 4 minus 4 into 3 is going to become 0. Okay. So this transformation will make these two elements 0. Okay. So, but you have to do it carefully. Okay. Each element you have to do carefully. 3, 2, 7, 0, So R2 I am doing like this. Okay. 3 into 4 minus 4 into 3, that is 0. Okay. Next 3 into minus 3 minus 4 into 2. So please do it carefully. Okay, so that is going to give you minus 70. Okay. So again 3 into minus 2 minus 4 into 7. So this is going to give me minus 34. Okay. This will be 0. Whatever coefficient you apply, it will remain 0 only. And here R3, 3 into R3, 3 into 5 minus 5 into 3, that is 0. 3 into 9, 27, minus 5 into 2, 10, so it's plus 17. So 3 into 23, 69, minus 5 into 7, 35. 69 minus 35 is 34. Okay, so next step, what I want to make this 0, right? So adding R2 and R3, you will get 0. So what I will do, the transformation is R3 equal to R3 plus R2. So what happens? 3, 2, 7 remains as it is. 0 minus 17 minus 34, 0, this remains as it is. R3 becomes sum of the two. 0 plus 0, 0, 17 plus 0, 0, 34 minus 34, 0. So now you see that one row has become entirely 0. Therefore, the rank of augmented coefficient matrix is equal to rank of augmented matrix equal to 2, which is less than the number of variables. Number of variables is 3, right? In this case, therefore, infinite solutions exist. Okay. So how do you determine those infinite solutions? Okay. So you look at this equation. Minus 17 y minus 34 z equal to 0, right? So you put z equal to some any random value. Okay. So let us say z equal to t, some parameter. Put z equal to t. Okay. So if you put z equal to t, what happens is minus 17y minus 34t equal to 0. So minus 17y equal to 34t. So y equal to 34t by minus 17 equal to minus 2t. Okay. So z equal to t, y equal to minus 2t. You substitute them in the first equation. Okay. The first equation is what? 3x plus 2y plus 7z, right? Three x plus 2y plus 7z. So substitute 3x plus 2y plus 7z. T, z equal to t, no? So 3x minus 4t plus 7t 0. That means x equal to minus t. Minus t, right? So the solutions are x equal to minus t, y equal to 2 minus 2t, z equal to t. So you put any value of t, you can determine the corresponding values of x and y. Okay. For example, if you put z equal to t equal to 1, the solution is z equal to 1, x equal to minus 1, y equal to minus 2. So that is one solution. So if you put t equal to 2, accordingly you can, so you will get infinite solutions, which you can represent it in parametric form like this. Okay. Okay, so I hope you understood this method of calculating the rank and determining the consistency and solving the equations. Okay. Any questions, doubts?
No, sir.
Okay. So I think with this, I'm going to stop discussions on matrices and determinants because I think we covered everything to my knowledge, whatever is there in your book. So now it is your job to make sure that you again revise your book. Every problem in your book you should be able to do. And if there is anything that you're not able to do, please revert to me. Okay?
Yes, sir.
Anything that you're still not understanding, you revert to me because next class I'm going to move to the next topic. Next topic, as per the Tamil Nadu syllabus, is complex algebra, right? So Vedant, has complex algebra, has it been covered for you?
Next chapter.
Next chapter, complex algebra, right?
Complex numbers, sir.
Complex numbers. So I will cover that complex. I will start with that. What about Prajjal? Is complex numbers, complex algebra, has it been covered for you?
No, sir.
No. Why? It didn't come in the 11th?
Yes, sir. In 11, complex number.
11th it is there now. So
Yeah.
okay, that means it's covered for you. So I'm going to, because for Tamil Nadu syllabus, it is in the 12th standard. Okay. So I'm going to cover the complex numbers. So we will take maybe 2 or 3 classes to cover all the concepts in the complex numbers. So that's what we will do next. Okay. So meanwhile, if anything, I'm assuming that you're good. As far as matrices and determinants are concerned. So any doubt, please get back to me. We'll come back later. Okay. After we complete all the chapters, we'll come back with more tougher problems. Or even in between, I'll conduct some tests. Okay. So that time we'll do some problems on matrix also. But no, now I'm assuming that we have completed this chapter. We're going to move on to complex numbers next. Okay?
Yes, sir.
Okay. If there are no questions, I will close the meeting now. Okay?
Yes, sir. Thank you, sir.
Thank you. Thank you. Yeah, bye.
காலையில நீங்க அவங்க கிட்ட நாங்க இன்னைக்கு வர்றோம் ஈஸியா இருந்தா இன்னைக்கு வர்றோம் சொல்லுங்க அப்படின்னு சொன்ன வருவாங்க அவங்க தான் ஈஸியே இல்லைன்னு சொல்லிட்டாங்க